All right, let's jump right into this explainer. When we hear the word syntax, we usually picture boring schoolhouse grammar, right? Red pens, rigid rules, diagramming sentences on a chalkboard. But today, we're actually going to completely reframe that. We're going to look at syntax as a fascinating cognitive science. We're going to trace the unbelievable journey of a single sentence, starting from the deepest, unconscious parts of your mind, all the way out through your vocal cords. And as a bonus, we'll see how the totally turbulent history of the English language actually rewired that entire process.
To help us map out our agenda today, covering language architecture, building trees, the linearization puzzle, information packaging, the loss of verb second, and finally how modern English adapted, we're going to use a continuous metaphor. Think of syntax as the architecture of a building. Linearization is this narrow hallway you have to walk through to exit, and information structure as the lighting that highlights the most important things inside that hallway. Let's start with the architecture.
So it all starts deep inside the brain, where generative grammar acts as the invisible mental architecture of our thoughts. And I really want to emphasize this. Generative grammar isn't some set of arbitrary style guidelines invented by English teachers. It's a fundamental cognitive property. It's literally the biological engine inside your head that organizes sounds into meaningful units and then words into complex phrases. It's the bridge between mere sound and deep meaning.
Okay, moving to section 1. Building trees and X-bar theory. Let's see how the brain actually constructs these ideas before we ever speak them aloud.
Notice the stark contrast here. When we read flat, linear text. But syntax doesn't build flat sentences, it builds three-dimensional hierarchical trees. In a flat structure, relationships are just a messy jumble. But in a mental tree, words branch into very specific pairs, establishing a strict vertical dominance. Linguists call this C-command. This is the whole basis of binding theory. It's how your brain instantly knows that in the sentence, John saw himself, the word himself has to refer to John. Why? Because John is physically positioned higher up in the mental tree, and C commands the reflexive pronoun. It's structural dominance.
And this brilliantly illustrates X-bar theory, which is basically the framework for how we construct these mental trees. The entire foundation relies on binary branching. You have a central head word that combines with a complement to form a core phrase, and then a specifier is added for context. But here is the crazy part. Any node in this mental tree can only split into two smaller branches, no more than 2 daughters per node ever. Much like a complex architectural blueprint, this incredibly simple binary rule, combined with recursion, which is just the ability to nest phrases inside of other phrases, allows us to build infinitely complex thoughts from a very finite set of rules.
Which brings us to section 2, the linearization puzzle. Going from 3D to 1D creates a massive puzzle. If our minds are building these expansive hierarchies, how do we actually push them out of our mouths as a single-file line of spoken words?
So the crucial point here is that what linguists call narrow syntax actually has no linear order whatsoever. None. This is your deep structure. The hierarchy is built and then it splits. One path goes straight to meaning, the conceptual intention interface. The other path goes to speech, the phonetic form. Linear order is only added during that externalization process, forming the surface structure that you actually speak. Your brain literally has to flatten the tree to force that 3D thought into the 1D hallway of your vocal tract.
To prove this, let's look at the fascinating case of echo reduplication in Kannada, which is a language that generally uses a subject-object-verb or SOV word order. On the left, we see the narrow syntax. It's pure hierarchy. No linear order, just the architectural blueprint of the sentence. But on the right, as the brain actually prepares to speak, the morphosyntax module steps in and immobilizes the tree. You see those little asterisks? Those are adjacency constraints. The brain is rapidly calculating what has to sit next to what, flattening the tree and forcing those words into that narrow hallway for speech.
And this older insight from cognitive scientist Carl Lashley perfectly aligns with these modern linguistic theories. Linear order just isn't in your core syntax. Your thoughts aren't inherently ordered in time. The sequence of words is a completely separate operation applied at the very last millisecond before you open your mouth.
All right, section 3, packaging information for listeners. Now that our words have been forced into a single file line, how do we package them so a listener can actually understand what's important?
This is where information structure comes in. Think of it as the lighting of our architectural metaphor. When you speak, you're constantly organizing information into 2 categories. Given information, which is old news the listener can easily recover, and new information, which is the actual point of what you're saying.
We instinctively use sentence structure to put the given information in the shadows, usually right at the beginning of the sentence to set the stage. Then, we put a spotlight on the new information, usually at the end.
Just look at how this plays out in the animacy hierarchy. The inherent salience of a noun heavily dictates where we intuitively want to place it in a sentence. Frankly, we are obsessed with humans, and especially ourselves. Speakers and listeners, I and you, are at the very top. Inanimate objects, like the rock, sit at the bottom. Because highly animate things are usually given information in a conversation, we naturally want them to occupy the most prominent early syntactic positions in our sentences just to set that stage.
Moving to Section 4, the loss of verb second. So what happens when a language's structural rules break down and suddenly collide with this psychological need to organize given and new information?
Well, let's look at the turbulent history of our own language to find out. Old English used something called a verb second rule. It was very much like modern German or Dutch. It was highly flexible. You could put almost any word at the front of the sentence as long as the verb came second. But by Middle English, this system completely decayed. And by early modern English, the language had locked into a highly rigid subject-verb-object, or SVO, word order. The verb was stuck, and the subject absolutely had to come first.
This rigid SVO order wreaked absolute havoc on English. Why? Because you could no longer just toss any given piece of information at the front of the sentence to set the stage. The front of the sentence was now exclusively reserved for the subject. As linguist Betelou Loss points out, the fact that a syntactic change destroyed our ability to light up our sentences properly proves that syntax and information structure are entirely separate modules in the brain. They clashed.
Section 5. How Modern English Adapted. To fix this massive communication breakdown, the English language had to invent some serious linguistic therapy.
Let's compare the two. Unlike Old English, which had super easy discourse linking because you could move basically any phrase to the front, modern English SVO structure is completely inflexible. If your given information, the thing you want to talk about, happens to be an object, well, you're in trouble. The only way to put that given object first in modern English is to completely re-engineer the sentence and turn that object into a subject.
And this brings us to how we actually fixed it. We literally created new grammar to survive. Because we desperately needed to turn objects into subjects to keep our given information at the front of the sentence, we saw a massive rise in the use of the passive voice. Actually, we even invented cross-linguistically rare structures just to satisfy this pragmatic need. Things like prepositional passives, the doctor was sent for, or complex constructions like John was said to be lying. We also started leaning heavily on it clefs to manually control the lighting of the sentence when the rigid hallway of our grammar got in the way.
So as you leave this explainer, I want you to listen closely to your own words today. Every single time you speak, you are building 3D hierarchical trees, flattening them into a 1D hallway, and using centuries-old grammatical workarounds, like the passive voice, just to make sure your listener gets the right lighting on your ideas. How is your brain navigating that path right now? Keep an ear out for it. Thanks for joining me on this incredible deep dive, and I'll catch you next time.